Hello, everybody, and welcome to this week's lesson. This week we are reviewing and building on the previous 3 weeks, units 1 through 3. So we will be reviewing and building on what we learned about whole numbers in the number system, ratios, fractions, and decimals. The materials you'll need for this lesson, you'll probably want your lesson notes from the last 3 weeks if you attended those lessons. You'll want your welcome packet next to you, pencil and paper as always, and you'll also want your calculator next to you. All right, our learning goals. So by the end of this week, you will remember how to round whole numbers and decimals to a given place value, identify absolute value of a number as its distance from 0 on the number line, determine the distance between two integer numbers on the number line, determine least common multiple and greatest common factor of pairs of numbers, solve real-world arithmetic problems using ratios, compute unit rates, order fractions and decimals, including ordering on a number line, and add, subtract, multiply, and divide with fractions and decimals. Whew, that's a lot of stuff. So again, these are our learning goals from the previous 3 units, the previous 3 lessons that we worked on together. So if you haven't seen those lessons, you might want to go back and watch those lessons first, but if you're up for a challenge, you can just dive right into this video. So what we're doing this week is we are in the review and study portion of the study cycle. The study cycle is something that I will talk more about in future study skills videos. Watch the study skills videos if you haven't checked them out yet. But reviewing is incredibly important for learning anything, but especially important for learning something that you maybe don't feel super confident about or you feel a little shaky on. Reviewing and repetition is incredibly important. There's basically nobody out there who can just look at something once and know how to do it. So this week we are going back over the previous 3 weeks. And when we review in math, we are not merely running our eyes over our notes. We're not merely sitting there and passively listening, because again, just sitting there and moving your eyes or just sitting there and keeping your ears open is not really going to help you learn and remember the material. You want to be actively learning. So you want to be sitting there with your pencil and your paper and trying each of the problems that we go through today first, before you listen to me talk through them. So I would recommend as we go through each problem, you press pause, you try the problem, and then when you have an answer or if you get stuck, you resume the video. What we're going to do today is we're going to go through 10 word problems that relate to those learning goals that we just saw in the previous slide. All right, so starting with the first question here, it says, what is the sum of 12.03 and 4.5? So this is something you can maybe do on a calculator, but we can also try it by hand. So let's do that. When we're adding or subtracting with decimals, we want to make sure we are always lining up our place values. This is something you do with whole numbers. It's something you also must do with your decimal numbers. So I'm going to line my numbers up by place value. You could fill in any empty spaces with zeros if you like to do that. And then we get started with adding, working right to left. So 3 plus nothing is 3. 0 plus 5 is 5. Bring down my point. 2 plus 4 is 6. And 1 plus nothing is 1. So my final answer is 16.53. All right, next problem. The table shows Miss Kayla's GED students' results from a keyboarding quiz. And keyboarding means the same thing as typing. What is the difference in words per minute, or WPM, between the fastest and the slowest typing student? Okay, so we want to know the difference in words per minute between the fastest and the slowest typing student. So first thing we need to do here is we need to figure out the words per minute for each student so that we can figure out who's fastest and who's slowest. So I'm going to add another column onto the table here where we fill in the words per minute for each student. Now, I would get your calculator out for this question. We don't need to sit here and do all of this division by hand. If you are not doing it in your head or you can't do it quickly on paper, you could use your calculator, but if you want to challenge yourself, if you want to practice those calculation skills, do it by hand. Okay, so Percy typed 90 words in 2 minutes, so he was doing 90 words in 2 minutes. And so his words per minute will be 90 divided by 2, which is 45 words per minute. Derek did 67 words in 2 minutes. So his words per minute will be 33.5 words per minute, right? We're dividing here. What we're doing is we're calculating a unit rate. This is something we practiced in Unit 2. So we're calculating a unit rate. We're making a comparison to 1, how many words in 1 minute. To do that, we divide. Next student, Tanisha. Tanisha did 84 words in 2 minutes. 84 divided by 2 is 42. So she did 42 words per minute. Connie, 70 words in 2 minutes. So that's going to be 35 words per minute. And finally, Frank. Frank did 59 words in 2 minutes. 59 divided by 2 would be 29.5 words per minute, 29.5 words per minute. Okay, so we just calculated the speeds. We calculated the words per minute for each student. Now we want to know, let's return to our question. We want to know what's the difference between the fastest and the slowest. So first we need to figure out who's the fastest and who's the slowest. Looking at my speeds here, 45, 33.5, 42, 35, 29.5. So I can see that Percy was the fastest. And I can see that Frank was the slowest. So finally, we want to answer that question, what's the difference between the fastest and the slowest? So now, how do we find the difference between two things? Difference means subtract. So I'm going to take the fastest speed, 45 words per minute, and I'm going to subtract the slowest speed. I'm going to line up these numbers. I'm going to add in a decimal point up here and a 0 just to make it a little clearer for myself. Okay, so 0 minus 5, we can't do that. So I'm going to come over here and borrow. 5 will become 4, and 0 will become 10. 10 minus 5 is 5. Now we have 4 minus 9. Can't do that, so I'm going to come over here and borrow. This will become 3, and my 4 will become 14. 14 minus 9 is 5. And 3 minus 2 is 1. So the difference in words per minute between the fastest and slowest typing student is 15.5 words per minute. 15.5. That means each minute Percy is typing 15.5 more words than Frank. All right, next question. What is the greatest common factor of 12, 24, and 48? The greatest common factor, or GCF, as we sometimes call it. Greatest common factor of 12, 24, and 48. Well, if you know your times table very well, then you might be able to look at these three numbers and you might be able to see right away that 12 is a factor of each of these numbers. 12 will go into 12 evenly, 12 will go into 24 evenly, and 12 will go into 48 evenly. So I know pretty much right away, because I've got my times table up here, so I got all those factors rolling around, I know that 12 is going to be the greatest common factor. But let's say you're not sure. What you would want to do is you would want to go through and list all of the factors for each of these numbers. So let's start doing that. So let's start with factors of 12. Now, when I list out factors, I like to list them out in factor pairs, so pairs of numbers that multiply together to give you 12. And I like to start with 1 and work my way up to have a little organization in my life. So 1 times what is 12? 1 times 12. 2 times what is 12? 2 times 6. 3 times what is 12? 3 times 4. And then the next thing I would want to write down here is 4, but 4 is already on our list, so we know we can stop there. This is all of the factors of 12. Now let's try factors of 24. Factors of 24. I'm going to go through the same process. So starting with 1, 1 times 24. What about 2? 2 times 12. 3, you could do 3 times 8. 4 would be 4 times 6. 5 is not a factor of 12, right? 5 times, it would be a decimal number to get to, oh sorry, 5 is not a factor of 24, misspoke. 5 is not a factor of 24, because if we try to do 5 times something equals 24, it's going to be a decimal number. We're just working with whole numbers right now when we talk about factors. So 5 won't work. We get to 6, but 6 is already on our list, so we know that we're done. And finally, let's list our factors of 48. So we're going to work through the same exact process. So 1 times 48. 2 times 24. 3, will 3 go into 48? 3 times what is 48? 3 times what is 48? 3 times 16 is 48. What about 4? 4 times 12 is 48. What about 5? 5 won't work. Can we do 6? We can do 6. 6 times 8 is 48. 7 won't work for 48. And now we've come back to 8, which is already on our list, so we know we're done. So let's look at our 3 lists here. We're looking for the greatest common factor. When we do that, we take our time and work carefully, we will see that 12 is the largest factor that all three of these numbers share. So 12 would be the greatest common factor for 12, 24, and 48. Now they have other factors in common. They have quite a few factors in common, but 12 is the largest. So here's a really good example again of how knowing your times table, knowing your basic division facts makes a huge difference for being able to work through a lot of these problems more quickly and more accurately. If you have your times table just sitting up here ready to go, then you don't need to spend your time writing out these lists necessarily. You can kind of run through it in your head and 12 would jump out at you. But if you're still working on your times table, take your time, right? Write out your lists. It's great practice. Next question. Gina sold 5/8 of a mushroom pizza and 3/4 of an onion pizza to the same family. How much pizza in all did the family buy? Okay, so how much pizza in all did the family buy? Well, we're trying to find a total, right? How much pizza in all? So how much pizza in total? What's the total amount? We need to take these two amounts and we need to add them together. We need to add 5/8 of a pizza and 3/4 of a pizza. So let's just visualize what's happening here with these pizzas. We've got one pizza that's cut into 8s. So 8 equal-ish slices. Just pretend that this is a perfect circle and there's 8 equal slices. We are talking about this family buying 5 of those slices. So 1, 2, 3, 4 slices plus another 5. So they're buying 5 out of 8 of those slices. And then the next pizza is 3/4. So I'm going to draw a circle that's about the same size pizza. It is cut into 4ths, 4 equal parts. And we're buying 3 of those 4 parts. 1, 2, 3. 3 out of 4. So we want to know how much pizza did they buy all together? Well, in order to total up the amount of pizza here, we're going to need to first re-slice our pizzas so that they have the same size slices, same number of slices per pizza. And that's what we're doing when we find the least common denominator of our fraction. So our first step in this problem is to find the least common denominator of the fractions that we want to add together. They must have a common denominator before we add. So what is the least common denominator of 8 and 4? Well, we want to think about multiples of 8 and multiples of 4. Multiples of 8 would be 8, 16, 24, and so on, right? I could keep going up. Multiples of 4 would be 4, 8, and so on. I could keep going up, but I don't need to because I just found the least common multiple of these two numbers. It is 8. So the least common denominator of 4 and 8 is going to be 8, meaning I could take this pizza that's cut into 4ths and I could re-slice it, get out my pizza slicer, I could re-slice it so that it is now in 8 slices instead of 4 slices. So I just re-sliced my pizza. Now I'm going to do that mathematically. So if you're not drawing pictures, how would you reslice your pizza? Well, we're gonna convert our fractions to have the same denominator. And usually what that means is we're gonna be raising one or both of the fractions. In this case, we're just raising one of them because the 5/8 is already how we want it to be. So I'm gonna take I'm gonna take 3/4. And I want to raise 3/4. I want to multiply the top and the bottom by the same number so that I end up with 8ths. Well, what do I need to multiply by? Well, when you just saw me reslice the pizza visually, I took each slice and I cut it in half. I kind of took one slice and made it 2. I multiplied by 2, right? So 4 times 2 is 8. Do the same thing up top. 3 times 2 is 6. So I just showed that 3/4 means the same thing as 6/8. And you can actually see that here in our picture, right? So I started with 3/4, but when I resliced the pizza, now I have a total of 8 slices. And 1, 2, 3, 4, 5, 6 of them are colored in. So 3/4 became 6/8. And now I'm ready to actually add because my fractions have the same denominator. So 5/8 plus 6/8 gives me 11/8, right? 11 yellow slices all together. Now our final step is always to simplify and make sure we don't have any improper fractions in our final answer. So I'm just going to call that simplifying. So let's take a look at 11/8. Can we simplify 11/8? So do 11 and 8 have a common factor other than 1 that we can divide by? No, they don't, right? The only factor that 11 and 8 have in common is 1. We don't need to bother dividing by 1. However, 11/8 is an improper fraction, meaning the numerator is bigger than the denominator. Or another way to think of it is that there is a whole number hiding inside of this fraction. We don't want to let the whole number hide. We want to bring it out front so that it is nice and clear that there's a whole number hiding in there. And in terms of this problem, it means that there is one whole pizza, or at least one whole pizza, hiding inside of this 11/8 fraction. So what do we do to take an improper fraction and change it to a mixed number, so a mixture of a whole number and a fraction? Well, usually what we do is we divide. So we say 8 goes into 11 one whole time, right? We can make one whole pizza out of 11/8. And then we're going to have 3/8. We're going to have a remainder of 3 left over. So 11/8 means the same thing as 1 3/8. If we were to take these yellow pieces and rearrange them, let's see what this looks like. We're going to rearrange them. We would see we have just over 1 pizza, so a little more than one whole pizza that they bought. So I'm going to have 8 slices, 8/8, plus another 3/8, right? This is 11/8, or we could call it one whole pizza and 3/8, 1 3/8. So A is our final answer. All right, Ryan has 30 pounds of cactus sand and is making tiny pots of various succulents to sell at the Mississippi Avenue Weekend Fair. If each tiny pot requires a 1/4 pound of sand, how many tiny succulent pots can he prepare for the fair? So we have a total amount of sand, and we're breaking it up into pots of sand, right? So we're taking our big bag of sand and we're gonna pour a little bit into each of these pots. Each pot needs a 1/4 pound of sand. We're taking a total amount and breaking it up into little pieces. How many little pieces can we make? How many pots of sand can we make? What do we need to do here? We need to divide. Anytime you're taking a total amount and breaking it up into little parts, you're dividing. So we're taking 30 and we're so 30 total pounds of sand divided by a 1/4 pound per pot. That's gonna tell us the number of pots of sand the number of pots of succulents that we can make. So 30 divided by 1/4. This is a fraction division problem. We're dividing by a fraction. Anytime you are doing a calculation with a fraction, especially if you're doing it by hand, probably what you want to do is you want to make sure both of your numbers are fractions. So we're going to take 30 and we're going to transform it into 30 over 1. Right, 30 over 1, it has the same meaning as 30, but now it just looks like a fraction. So 30 over 1 divided by 1/4. How do you divide by a fraction? Well, you keep the first number the same. So 30 over 1 just stays as it is. You change the division to multiplication, and you flip the second number. You flip the second fraction, you find the reciprocal. So 1 over 4 is going to become 4 over 1. And now it's just a multiplication problem. Multiply straight across. 30 times 4 is 120. 1 times 1 is 1. So this fraction will simplify to 120. So if he starts off with 30 pounds of sand, each pot needs a 1/4 pound, he can make 120 pots with that 30 pounds of sand. I'm gonna sneeze. Excuse me. So our final answer here is 120 tiny pots. Put the following numbers in order from least to greatest. 15, 1.0005, 3/2, and 1.005. So I look at this and I see I've got a mixture of whole numbers / decimal numbers and then this one fraction. So what I'm gonna do is I'm gonna take my fraction and change it into a decimal to make my life easier. How do you take a fraction and change it into a decimal? You divide. So 3/2, 3 divided by 2. 3 divided by 2 is 1.5, right? If you have $3 and you split it up amongst 2 people, each person gets $1.50. They get $1.5. Okay, so now I'm going to write out my list of numbers that are all either as whole numbers or decimals. I'm going to write them out, being sure to line up the place values so I make sure I'm comparing the right thing. So 15 was the first number. And then I have 1.0005. And then came 3/2, which was 1.5. 1.5. And finally 1.005. We want these in order from least to greatest. One thing you might find helpful is to fill in your empty spaces. So I'm gonna add a decimal point here, and I'm gonna fill in all of the empty spaces, right? What does emptiness mean? It means nothing, it means 0. That might help you compare these numbers. So least to greatest. Looking at my numbers here, so 1, 5, and 1s, 0s, and 5s, 0s, 0s, 5s. So 1.0005, this is the smallest number. It has 0 tenths, it has 0 hundredths, 0 thousandths, and only has 5 little 10 thousandths there. So 1.0005 is going to be our smallest number first on the list, 1.0005. What comes next? Next up is going to be 1.005, right? It's got 0 tenths, 0 hundredths. It just has 5 little thousandths there. So 1.005. And then we would have 1.5, right? 1.5 is certainly smaller than 15. So we're gonna have 1.5 next on our list. We know that 1.5 is actually 3/2. So I'm gonna write the original number on the list. And that means our largest number is 15. And there we go. We have our numbers in order from least to greatest: 1.0005, 1.005, 1.5, and 15. Order the following fractions on the number line: 1/2, 7/8, and 3/4. So we've got 3 fractions here. As I mentioned in the last lesson, anytime you're given a number line, you want to take some time to check out the situation, see where your number line starts. It starts at 0, see where it ends at 1. And I see that the space between 0 and 1, this whole number, has been broken up into parts. You want to think about what are the parts it's been broken into. So what is the interval of this number line? What does each little jump along the number line represent? Well, the space between 0 and 1 has been broken up into 1, 2, 3, 4 parts. So this whole number has been broken up into fourths. So this first part, traveling from 0 to my first little line, that would represent 1/4. And then 2/4. What's another name for 2/4? Can you simplify 2/4 at all? I bet you can. If you simplify 2/4, we'll see we get 1/2, right? Notice that this line is halfway between 0 and 1. Okay, back to counting by fourths. We had 1/4, 2/4. Up next would be 3/4. And then we get to 1, we have 4/4. So right away, actually, I can just put 2 of the fractions on my number line here because I took some time to think about how my number line was set up. So 1/2, right, is going to be at this halfway point between 0 and 1. 1/2 means the same thing as 2/4. So I'll call this 1/2. And then 3/4 is also right here. I can just put a point here for 3/4 and I'll label it just so it's clear that this is one of my numbers. All right, now 7/8. 7/8. Where does 7/8 belong on this number line? Well, if I think about what 7/8 means, 7 out of a total of 8 parts, that's pretty darn close to 1. So we know that 7/8 is going to be somewhere probably in this area. It's going to be closer to 1 rather than closer to 0. So one way that you could figure out where 7/8 belongs is you could look at a line, a tick mark on your number line that is labeled. It's labeled with 3/4. And you could find a common denominator between 3/4 and 7/8 to help you compare. So that's one way that you could think about this. 3/4 compared to 7/8. Well, to compare, we want a common denominator. Common denominator between 4 and 8. We already saw that in an earlier problem. It would be 8. So I'm going to take 3/4. We already did this. We already raised 3/4 to 8. 3/4 becomes 6/8. Right? If I multiply the top and the bottom by 2, I get 6/8. So 3/4 means the same thing as 6/8. So if this is 6/8, add that. This is 6/8. Where does 7/8 belong? Well, we can kind of imagine halfway in between here and 1 would be 7/8, right? Before we finally get to 1, which would be 8/8. So 7/8 is halfway in between 3/4 and 1. Another way that you might think about this, and this is how I would think about it. The space between 0 and 1 has been split into 4 parts. If you want to split it instead into 8ths, what you would need to do is you would need to go in and cut each 4th in half, right? So if I do this, now I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Right, so taking each 4th and making it 2 pieces will give you 8ths. That's another way you could do this. You could look at this number line and re-slice it, right? We've talked a lot about re-slicing with our pizza cutter here. You could re-slice it into 8ths, and you'd see that 7/8 belongs after the 3/4 and before the 1. All right, so we've got our 3 fractions on the number line. Let's move on. A couple traveled 2,871.46 miles cross-country and averaged 31.2 miles per gallon. How many gallons of gas did they use, rounded to the nearest tenth? Okay, so what do we need to do here? They went 2,871.46 miles, so that number of miles. And they were doing 31.2 miles per gallon. So how many gallons of gas did they use? We've got a total number of miles. If we divide that up into 31.2 miles per gallon, that'll give us our total gallons that we used. So we're doing the total miles divided by miles per gallon. That should tell us the number of miles we traveled. So we have, I'm gonna get out my calculator here, 2,871.46 divided by 31.2. That gives me 92.033397.436. There's a lot of decimal places after that. I don't need to worry about all of those decimal places because I'm being asked to round to the nearest tenth. So I just need to take this number out to one place past the tenths so I can think about how to round. So which digit here is in the 10th place? The 0 is in the 10th place. So I look next to it. I look to my 3. My 3 tells me I should round that 0 down. So 0.03 would round down to 0.0, become 92.0 miles. Sorry, gallons. I keep saying miles. I meant gallons. 92.0 gallons, right? So total miles divided by miles per gallon will give you your total gallons of gas. One thing I recommend, especially in word problems, is if you're looking at the word problem and the numbers are throwing you off when you're trying to think about what to do. So maybe you have fractions or decimals or really big numbers and it's kind of overwhelming you and you're not sure, like, should I be adding, subtracting, multiplying, dividing? One thing that can sometimes be helpful is to just replace the numbers you're given with simpler numbers. And that might help you think through the problem. So let's try that here. Let's say instead of 2,800 blah, blah, blah miles, let's just say, let's say they traveled 100 miles. They traveled 100 miles and they got 50 miles per gallon. So 1 gallon of gas will get them 50 miles. How many gallons of gas did they use? They went 100 miles total, and 1 gallon can get them 50 miles. So how many gallons did they use? They used 2 gallons, right? So 1 gallon will get them 50, and then another gallon will get them up to 100. They used 2 gallons of gas. So what calculation did we do there? We did 100 miles divided by 50 miles per gallon gives us 2 gallons of gas. So thinking it through that way with simpler numbers might help you realize you need to take your total miles divided by your mileage, your gas mileage, and that will tell you the number of gallons that you need. And then once you do that, once you kind of got your plan set up in your head, you can return to those original numbers. You can return to those original numbers with your plan to divide. I often find that that strategy of picking simpler numbers helps a lot with fraction and decimal problems, where those fractions and decimals might cause you anxiety, right? Just replace them with some nice, easy whole numbers and think about, would I add, subtract, multiply, or divide here? What do I need to do? And then whatever your plan is, you just do that plan with the original numbers, the fractions and decimals. All right. What's the distance between points A and B on the number line below? So I've got point A here, and I've got point B here. What's the distance? Well, I just need to travel from one point to the other. So here I am. Here I am at point A. I'm going to travel to point B. And when I look at my number line, I forgot my first step here. When I look at my number line, I got to take a minute to figure out what the interval is, right? Each time you move up a space, how much are you moving up by? So on this number line, I can see it's counting by 3s, right? It goes from 0 to 3, -3 to 0. It's counting by 3s. So A to -9 would be 3, 6, 9, 12, 15, 18. The difference between, the distance between A and B is 18, because we're counting by 3s. And that's the distance. That's all there is to it. We just gotta take a minute to realize that this number is set up to count by 3s and then you just travel from A to B. All right, a town has a population of 20,510 and an area of 86.8 square miles. To the nearest tenth, what is the population density as measured by people per square mile? So we want to know the number of people per square mile. So I'm going to abbreviate square miles like this. The number of people per square mile. This is another unit rate question where we want to make a comparison to one, right, to 1 square mile. So how do we calculate a unit rate? We divide. We're going to take our total people, our population, 20,510 people, divided by our square miles. So 86.8 square miles, divide, get out my calculator here, 20,510 divided by 86.8. Oops. 20,510, let's try that again, 86.8 gives me 236.2, so that's the 10th place, 9, that's the 100th place. There are more numbers on there, but I don't need to worry about it because I'm rounding to the nearest 10th. So now I'm going to identify my 10th place, that's the 2. I look to the number next to it to help me round. It's a 9 there, so I'm going to round, instead of 0.29, I'm going to round up to 0.30. Round up to the nearest 10th. So this rounds up to 0.3. My final answer is I have about 236.3 people per square mile in this town. Okay, so those are all of our reviewing and building questions for this lesson. We're going to continue with some very similar problems in the homework for this week. But I just wanted to talk a minute as we wrap up here. I want to talk about what is up next. So the previous 3 lessons, units 1 to 3, we have been working on kind of our foundational number skills, talking about our number system, number lines, whole numbers, decimal numbers, fractions, ratios, all of our foundational number skills, getting us ready for our next units. So what's up next? Unit 4, we're going to be working with integers and rational numbers. So that is more practice working with positive and negative numbers. Unit 5, ratios, proportions, and percents. So our ratios, we've already talked a bit about. We're going to be building on that knowledge with proportions and percents. Proportions and percents are things that we use all the time in real life. If you've ever calculated a sale price in your life or attempted to, then you were working with percents and proportions. And then unit 6, we're going to do some work with data and statistics. So that means we're going to be looking at graphs and charts. We're going to be finding averages of numbers, things like that. Units 5 and 6, we're hopefully going to be doing a little collaboration with Miss Alex's lessons those weeks. So our topics, the topics and problems that we cover in math class are going to be connected to the work and the reading that you're doing with Miss Alex. And we're going to be doing some learning about government and civics, and hopefully it'll be interesting and relevant, and you'll learn a lot during those units. So that's what's up next. The plan for this week, it's set up a little bit different this week just because we have, it's our review week, so a little bit less new material. To do for this week on the Google Classroom, you've got a vocabulary review to do. So that post will be up on the Classroom. You're just going to be going back over our vocabulary list for the last 3 units. You'll have a worksheet Wednesday assignment on Wednesdays, so 10 problems, similar to the problems we just did together. You'll have a study skills video on the study cycle for Thursday. And I also encourage you to try or retry assignments from the last 3 weeks, the last 3 units. So on the Google Classroom, that would be August 17th to the 21st, 24th to the 28th, and then the 31st to September 4th. All right, everybody, thank you so much for joining me on this lesson, and I will talk to you all very soon.